level. And well, I guess we'll start there and then we'll get Patrick up.
Oh, I thought Representative Webb. Didn't find anyone else.
I pushed the button with help from others.
Good morning.
Good morning.
My name is Jeff Nelson, and I'm Director of Energy and Environmental Services with DHB in South Burlington. And first of all, I appreciate the willingness of the committee to reschedule your day, given my schedule that will go to Vermont later today. So thank you. And I do have copies of what I'm going to be using. Actually, here's several. And
Yeah, you can give the rest to Shannon and
Thank
she'll
you.
distribute. Thank you.
Okay, so
Just play out in front.
okay, so I've been involved with several projects that have included the use of level spreaders, and what I focused on in particular in the written memo that I prepared is the Kingdom Community Wind Project in Lowell that we worked on beginning in about 2011, I believe. And this project was constructed with an approved stormwater permit from DEC, and included both traditional, what I call traditional stormwater ponds, and level spreaders. And one of the materials that I've given the committee is a blown up photograph that illustrates two of the level spreaders at Kingdom Wind. And I guess the first thing I'd like to note is that when we say the word level spreader, that's really shorthand, if you will, for a treatment system that involves several components. The level spreader is one of those components, and in the picture, the level spreader is actually this trough and this lip that you see in basically the center of the picture. So the picture on the left-hand side, the trough is here and the lip is here. And in the right picture, this is the trough and this is the lip. So what happens with these level spreaders is that the stormwater runoff from a section of a roadway comes into the device, and typically, as you can see in the picture on the right, there's a stone-lined swale. The runoff, when it rains or when you have snow melt, comes down through that swale, and obviously it's stone-lined because it's a steep slope, and it needs to be stone-lined to prevent it from eroding. The water then comes into the pool and spreads out, and as the storm continues, or the snowmelt continues, the water level slowly rises up and flows over the lip of that spreader, which is level, hence the term level spreader, and then disperses out across the terrain that is below. So in the case of the level spreader on the left, you can see there's some stone that is immediately below the lip, and the one on the right is more vegetated. That's a function, that design is a function of the conditions, the amount of water that's coming in, the velocities, the slope of the ground. But then the next part of the level spreader, which doesn't really get talked about very much, but is as important as what you see in the picture, is what's called the vegetated buffer. So for a distance from the lip downhill of 150 feet, the vegetated buffer is intended to allow for the continued dispersion, infiltration of the runoff as it leaves the device. And that area is part of the treatment system. It can't be, you can't put a road in, you can't cut those trees. That has to be protected because it's part of the, what I would call polishing of the stormwater as it proceeds from the level spreader downslope. So that's how they work. And then I guess the other piece I wanted to touch on with respect to these devices is why bother? What's you know, there's been a lot of discussion about level spreaders. Why do it? stormwater manual, and you know, we use the stormwater manual in my firm on a daily basis for various stormwater designs. A lot of the treatment systems in the current manual, the 2002 manual, are really well suited to what I would call large rectangular sites. So if you're building a shopping center or a big, you know, retail development or something that's large and relatively flat, the manual has ponds and other devices that are well suited to that. But when you're on a mountainside, when you try to make something large and big that's flat, because it has to be flat so the water can stay in it, that involves a lot of ground disturbance, a lot of tree clearing, that, in our opinion, is unnecessary. And what we have achieved with the level spreaders, which are an alternative design, they're not an experimental system, they're widely used around the country, is something that greatly reduces the amount of tree clearing, the amount of grading, and also allows a designer to better distribute that stormwater runoff to maintain the natural hydrology of the mountain. So, as I mentioned at the outset, in the case of Kingdom Wind, there are 31 level spreaders. Each of those handle a very small amount of runoff. In fact, one of them only handles runoff from 1/10 of an acre of roadway. Very small amounts of runoff that are sent to these, distributed out through the spreader and into the natural terrain to try to keep that stormwater as close to possible as where it would occur under natural conditions, rather than taking all the stormwater from an entire site, collecting it via catch basins and pipes and bringing it to one location for treatment, and then discharging it at that one location. We felt, and DEC, through the issuance of the permit, agreed that dispersing that runoff more natural, more consistent with the natural runoff patterns was a good idea. So, given that this was not what is titled in the manual and quote-unquote accepted stormwater treatment practice, there was some special monitoring that was attached to the permit. And that monitoring was intended and is intended to evaluate the specific performance of these level spreaders in terms of removing pollutants. What am I talking about with pollutants? That would be sediment, phosphorus, nutrients, other nutrients that come from the roadways that need to be managed in accordance with the stormwater manual. So that monitoring is one of 3 kinds of monitoring that's being done as part of the project. And on the 3rd page of my handout, the write-up, I describe those 3 kinds of monitoring that are being done. The first kind is what I would call the sort of routine monitoring of a stormwater system. So any stormwater system is not a build it and forget it type of situation. Once you build the stormwater system, there's ongoing inspection, ongoing maintenance, ongoing reporting to DEC that's required. And that's been going on for Kingdom Wind. Basically we're doing about 3 times the required amount of inspection and reporting between what GMP staff on site do and what VHB staff under contract to GMP do. And so that reporting goes into DEC as required by the permit. The second monitoring is watershed-based monitoring, and I'll speak to that in a moment, and that's really looking at the overall water quality of all the streams in the vicinity of the project. But then the third one is the alternative design testing. So as I mentioned, because the level spreaders are not what's considered an accepted treatment practice currently in the manual, the permit required this special testing to be done to evaluate how they were actually doing in pollutant removal. So that testing has been intended to begin once the project is constructed, and we have been working with the agency, with DEC, to obtain a study plan that they were satisfied with and be able to move the work forward. As of earlier this year, the study plan is fully approved. We had several site visits. The agency folks wanted to confirm the locations that we were monitoring. We've selected 3 of the level spreaders that are representative of site conditions, ranging from the amount of impervious area that they treat to the steepness of the terrain that's down below them, and a bunch of other factors that were considered in selecting what is quote-unquote representative. So
How many sites?
we're monitoring 3 sites, out of the 31. And so that monitoring will begin later this spring. All of the equipment that's required for it has been ordered and received, and our staff are working with GMP staff on site to implement that monitoring that's required per the permit. So taking then a step backwards to the watershed-based monitoring, and that's the large display sheet that was one of my handouts. So one of the things that was not part of the stormwater did you want?
No, thank you.
Yes,
I want a
I-
question. So I think you've confirmed an assertion that was made in this committee the other day that the monitoring of the spreaders has yet to begin. And if I understood what you just said correctly, but I guess, could you just flesh out a little bit more, and I presume we are under we're under the floor, on the floor at 10. But could you tell us a little bit more about why it's taken so long?
Sure.
Equipment, whatever,
Yep.
and why only 3 sites out of 31?
Yep. So the timing of the special study, the permit condition requires that the study not begin until at least a year after the site construction was completed, and the reason for that was basically to allow everything to be stabilized, if you will, make sure that the system was in what I would call an operational mode as opposed to a construction mode. So that the
That date was?
pardon?
That date was?
So the completion of construction in terms of filing the notice of termination with the construction stormwater permit was late summer of 2013.
Yeah.
So it wasn't intended to begin until late in 2014, and at that time we were working with DEC on the study plan and making adjustments to it through. It was really too late in 2014 to do much by the time you're getting into fall, and this is really testing that you want to be doing during the summer when we get larger storms. So in 2015, we had 2 or 3 site visits. There was a question about the locations of the monitoring, the number of level spreaders to be looked at, and admittedly that work could have gotten pushed faster, but between our staff and their schedules and DEC staff and their schedules, there was a lot of work going on to get the study plan finalized and agreed upon, but it didn't get done in time to do any actual on-the-ground monitoring in 2015. I don't have much more of an explanation than that, but it is approved now, and the equipment is ordered and received, and it will be occurring as soon as spring conditions allow this year. On the topic of why 3, I guess that's really a question of study design, and what we tried to capture in the 3 that were chosen is a representative subset of the systems in terms of as I mentioned, the amount of roadway, the amount of impervious surface that goes to them, and the conditions, the steepness of the ground, and just generally kind of how they had been responding since they've been constructed. Could you do 5? Could you do 2? Sure.
Could you characterize the 3? The steepest ground possible, the levelest ground possible, somewhere in between, the Goldilocks level. I mean, why these 3?
Yeah, one of them is. Yeah, one of them is on this. I don't want to say the exact steepest ground, but pretty close to it. One of them is handling among the largest amount of impervious area, so it gets the most water. And then the third one, if I'm recalling, is kind of sort of in between. So those were some of the criteria we used, frankly, that was a big part of DEC's review. They wanted to see these level spreaders in the field. They wanted to be comfortable that this was not a cherry-picking exercise. This was really looking at the range of spreaders that were out there and how they were operating in the context of the overall stormwater treatment system.
So the agency helped you select, or agreed to the site select?
They field reviewed and approved those 3 locations, and certainly I'll let Patrick speak to his staff's work. No.
Just sort of curious, general opinion, even though you hadn't started monitoring,
Yep.
water quality wasn't compromised, or was it?
No, not at all. You know, and that's why I tried to emphasize the 3 tiers of monitoring. We have the routine inspections and reporting. So what that's telling us is that the level spreaders aren't washing away. I mean, that they're not eroding, that they're actually physically intact. They're not filling up with sand. They're doing what they're supposed to be doing in terms of their presence on the landscape. And then the watershed monitoring of all the streams surrounding the ridge is telling us that the project is not impacting the water quality of those streams. So those, we have those, you know, it's not as though we don't know anything about what's going on. We have those 2 pieces of information, which frankly is more than you would ever have for any other kind of project. If you go to build a Walmart or something, you're not doing this kind of monitoring. So
The reason I asked that, Jeff, is the tone of some of the correspondence, at least that I get, is because the monitoring hasn't started. There's a permit violation, and of course, everything's getting polluted. It's not that
that's
way.
absolutely not the case.
Thank you.
So I guess the one other piece I wanted to touch on is the big chart of the map and the data. So as I mentioned, one of the other kinds of monitoring is this watershed scale monitoring, where we're looking at all the streams surrounding the project. We do chemical sampling, we do physical sampling, like looking at the bottom of the stream, and is it silty, is it sandy, is it gravelly? We do biologic sampling, so we're looking at both the fish in the stream and the aquatic insects, otherwise known as macroinvertebrates. And what this display shows are first all the sampling locations that we are looking at, and these sampling locations again were presented to, reviewed, and approved by DEC biologists as part of the requirements of the water quality certification for the project. And then on the right-hand panel are the actual results of the macroinvertebrate sampling. So these are the bugs in the stream, and if you look in the lower left, you can see one of our folks in the stream collecting the bugs. So it's basically a process by which someone goes out and does what's called a kick net sample, dislodges the, Dave, you know a lot about this, I'm sure, but it's the insects that are attached to the bottom of the stream, and DEC has established very robust protocols for different kinds of streams, whether they're steep streams, moderate streams, or flat gradient streams, to assess the number of bugs, the types of bugs, and what they're representing in terms of the quality of the stream. Vermont, frankly, has been way ahead of the curve nationally in terms of using biologic indicators to assess the health of streams. So what you see here with all these segmented pie charts is a picture of what's been going on in all these streams ever since 2010, before the project even started construction, and going through to the most recent data from 2015. And you know, we could really dissect this information pretty intensively, and you know, there are folks at DEC that are they're biologists that's what they do, is look at this data. But in summary, what I can tell you is that if you look over time, there is variability at the stations, and if you look between the stations, there is variability within a given year. But what we're not seeing is any trend or any indication that any of the stations are being adversely affected by the project. No one station is perfect, no one year is perfect, but that's just the nature of variability that you would expect in a natural system. And you know, that's my professional opinion, and I would defer obviously to agency biologists for their review of our data, which they do in the context of these submittals, to provide their own input on that.
So the real comparison ought to be the pre-construction versus all the other columns.
Correct. So, you know, when we look at the, like, for example, the first station at the top of the page, WQM1, in 2010, that station had 7 of the 8 metrics that we calculate being in the green. So those metrics were met. Then there's this kind of gray area, which is called indeterminate. And one of the metrics, the density metrics, which is in the upper right quadrant of the pie, was in that indeterminate zone during 2010. And then you can see during construction, that stream remained green, the pie remained green for the 2011-2012 year. Went into operation, we had a lower reading of density at that station, but then 2014-2015, the pie is fully green again. So it just, there's variability, and sometimes if you have a high flood event before, or a big storm event before the monitoring takes place, that can flush some of the bugs out of the system, or if you have low flows, a drought condition, then some of the populations can be depressed. So it varies from year to year as a result of a lot of different things.
Jeff, do need that second handout, please. I expect we want one for each member as well. But
Yep, I think, yeah, there's enough. So, you know,
thank you.
Okay, maybe just translate for me. PPCS-FG. That one I don't know.
Pinkham-Pearson coefficient of similarity, and the FG is feeding groups. And so it's looking at different kinds of bugs, whether they're shredders, whether they're shredding the leaves, or they're, you know, they're doing it. It's just, it's a you know, I guess.
Do you find across the
Right,
spectrum
the different
what you're
kinds,
looking
right,
for?
exactly, yeah,
Okay.
whether, you know, the different groups. And, you know, I mean, so essentially what happens here is that the bugs are collected, and you might have 500 bugs collected at a given station, and then taxonomy is done, they're all, you know, indexed to what species and so forth, and then the metrics are applied, and DEC has developed these metrics to basically look at different things. So for example, one of the metrics is percent, it's listed here as percent olig, which is percent oligochaetes, and these are aquatic worms that are found in the bed of the stream. If you have a station that has a very high percentage of oligochaetes, that means there's a problem. Right. There's a lot of silt, there's a lot of sand, so that particular indicator in the pie, the slice of the pie that's to the left, just below the middle, is the one that you look at to see if there's excessive sand load. And you can see none of these stations in none of these stations has that been anything other than green. So, you know, that's a great indicator for looking at sand load. And that, you know, and we use that, and the agency uses that. Like when we did the water quality remediation plan at Sugar Bush, Rice Brook, the percent oligochaetes was off the charts because there was a lot of sand that was running off from the parking lots getting to Rice Brook. When the stormwater systems got put in, the percent oligochaetes came down to where they should be for this kind of stream. Similarly, the EPT are the water quality sensitive organisms, and if you make me, I'll tell you, it's ephemera, Plecoptera, Trichoptera. So if you have low EPT, that means that there's an impact to water quality, maybe it's nutrient enrichment, or, you know, a toxicity issue that is causing that particular group to be depressed. So, and again, those are all green. So, you know, the 8 metrics, each of them is looking at a slightly different thing, but on an overall basis, they're looking at the health of the stream. And that's, you know, that's really what I was trying to summarize here in this slide.
Just so it's on the record so that I understand it, Jeff, a lot of this whole monitoring thing, is that condition 14 out of this stormwater discharge permit that you're talking about?
That's correct, yep. So this is the permit 6216-INDS, and condition 14 is where the monitoring requirement is embedded.
Also, tell me briefly, after it goes through these level spreaders and it hits downhill, does it tend to reconcentrate just due to natural topography then?
Well, not in an observable way, but I guess, you know, looking at hydrology of a mountain setting, you know, as you come down further in the watershed,
Yeah.
you get little rivulets of water that coalesce into streams and coalesce into larger streams. So we can't trace from the level spreader, we can't trace a rut, if you will,
Okay.
that is indicative of the stormwater. But as you go down further in the watershed, you hit a stream or a wetland that's you know, was present before the project existed and is still there, and that's where the water ultimately discharges, although you'd be hard pressed to go out and say, it's not a pipe, you know, it's not like a stormwater basin where you have a pipe, you don't see it. And that's the whole idea of this, is that we're dispersing that water so that you don't see it.
And last thing, all your sampling, I assume you try to mark those so it's the same spot all the time?
Yep, there's established sampling locations that are pinned, if you will. There's a you know, permanent
Yeah.
marking. We don't have a big sign that says sampling location because we don't want it to be disturbed. But all of our scientists and DEC folks, when they do their replicate sampling, know where the sampling location is.
Okay, thanks.
Just, I want to follow up where this question started, which is condition 14.
Yep.
Within 6 months of close of the 3-year monitoring period, prepare yourself submit a written report. Does this represent a 3-year monitoring period? Is that what this represents?
No.
Because there are 3 years
Yeah,
there.
right.
And so,
No, this condition is intended to be applying to the special study of the level spreaders. So the chart that you see there is really from the 401 monitoring, the water quality certification monitoring.
Okay.
So, and there's obviously
so
more.
this isn't condition 14?
That is
right?
correct,
Okay.
yes. Yep.
And has that report been submitted?
No.
Again, I don't understand the time.
Right. No, it has not, because the monitoring is underway as of 2016. So that will not be submitted until we finish doing the monitoring.
So you have to go through this field season before the 3-year clock has run?
Well,
Or until the trigger?
right.
started
I mean,
to run?
we will discuss with DEC when the end of the 3 years is. And I'm not trying to be evasive, but what I'm trying to explain is that if we get a sufficient number of rainstorms that are monitored this season that reflect the magnitude, intensity, duration of the storms that we want to see to test the level spreaders' performance in removing pollutants, we may have plenty of data to get all the measurements we need to get in 2016, in which case we will write the report, submit it to DEC early next year, so about a year from now. On the other hand, if it's a dry summer and we don't get much rain that really is worthy of actually testing the system, then we probably won't. So it's, you know, we just need to kind of see what happens, and the study plan is designed to make sure that we are getting the measurements that we need to get from, you know, a big enough storm event to see that they're working. I mean, we're not going to go out and monitor when there's a 1/10 of an inch of rain and nothing much happens. So.
Okay, so it's difficult to mark the start, difficult to mark the end. The target is 3 years if you get the event you're
Right.
looking for.
Yeah, correct. But I will say, because there's been some suggestions otherwise, both VHB and GMP are 100% committed to doing this work and doing it right and making sure that the data is scientifically valid and is usable by everybody, because that's, you know, otherwise, why bother doing it? I mean, this is important information. It really, it tells us how well this technology is working, and it's going to be usable for the future, for maybe for wind projects, maybe for other kinds of projects, and so we're committed to doing it right. And I can't emphasize that enough, because some have suggested otherwise, but I just, it's not true.
So, question, I know how hard it is to make things level, and in freeze-thaw cycles, how hard it would likely be to keep them level.
Right.
And so, so the first part of that is there plus minus tolerance for the spreaders? What would that, what is that? And then I would imagine, even though we haven't had the rain events, to test the levelness of the spreaders would be shot every year to see that they're maintaining level status, whatever plus minus that is. Is that accurate?
Yep, good questions. And so the freeze thaw is a real cycle, is a real challenge for designing level spreaders in northern climates. And when this was under consideration, a lot of different techniques or materials were considered for the spreader. Like in some places they'll use like a wooden beam or a concrete lip. And the concern was that those would get out of level because of freeze-thaw. And so what we ended up going with here is a densely packed, and you can see it in some of the pictures, stone, crushed stone. And what we saw, and the tolerance, quarter inch to a half inch over the length of it, which is pretty tight. What we saw was in the first year, even with the compaction that was done on the lip, there was some settlement in some of the spreaders, and GMP went back in as part of the routine maintenance, because that was observed during these inspections that are being done, already. And so they went back in, put additional material in, recompacted it. It was not in a large number of the spreaders. I don't remember the exact number, but I want to say less than 10 had to be, touched up. And since that time, they've been fine in terms of maintaining level and distributing the flow. We don't actually go out and shoot the elevation of them each year, but the way we observe how level they are is look at them during a storm.
See the grass.
Well, that too. But if you go out during a storm and there's a lot of water coming in and it's distributing, is it going over the whole thing or is it just going over one end?
Yeah.
That's how we've been doing it.
Yeah. Good, thank you.
Other pressing questions, because I really would like to get Patrick up here in a few minutes and talk with
Just
the
one,
agents.
yeah, no, quick one. Have you picked the 3 sites that you're going to be monitoring?
Yes, we have.
Any of them the same as these?
Well, the level spreaders actually don't show up on this drawing. They're at various places around the site. They have been picked, and some of them, I don't remember, I think one of them is up on the crane path, and 2 of them are on the access road, if I remember correctly. So,
All right, thanks.
Yeah, it would have to be the access road if you want steep.
correct.
Yeah.
Yep. Yeah, and we did use a lot of level spreaders on the access road because it's sort of cutting across the slope, and it was a, it was a really good technique.
I've been there.
Yeah. Thank you for your time.
Yeah, thank you. Patrick.
Good morning. For the record, I'm Patrick Monks. I'm Vermont DEC Stormwater Program Manager. I think one point that's important to understand regarding level spreaders will actually be 2 points, and Jeff did a good job describing it. Level spreaders are not a treatment practice in and of themselves. They're a component. But looking back a little further into the past, in around, I think it was around 2009, the legislature directed us to consider or to develop a different suite of stormwater management practices for high elevation renewable energy projects. And we did that. We didn't have any particular projects in mind. We undertook a fairly extensive stakeholder process and updated the stormwater manual to include that new suite of practices through rulemaking. What we came up with is called the Watershed Hydrology Protection Credit. It's part of the stormwater manual. And our goal in developing that credit was to require that roads that are being built to that credit or other structures preserve the existing hydrology of the watershed to the maximum extent that they can. And we did that through One, looking at existing steep, high elevation roads in the state, looking at existing practices or regulations in place in Vermont and other states, including the forestry AMPs. And some suite of practices we came up with, we being the stakeholder group and the department, ensure that water isn't collected and kept in the road ditch network for a significant amount of time. It's bypassed frequently. There's requirements related to stream buffers. Again, frequent bypass of stormwater. Once it's in the ditch, it can only go a certain length before it has to be directed out of that ditch network, similar to the forestry AMPs. What's different in the watershed hydrology protection credit is that it's not just bypass that water out of the ditch, but it's also releasing it in a very controlled fashion through the use of level spreaders and over a specified distance of essentially naturally vegetated terrain. So again, as Jeff described, in a typical conventional stormwater system, that water could be collected over a very substantial length distance and collected and managed in a single structure. What we sought in developing the watershed hydrology protection credit was a way to allow water to continue to move down the hillside very much the way it does now when it is picked up and collected, to re-release it in a distributed fashion as frequently as possible. I mention all that because we describe level spreaders as one as a practice and also as an alternative practice. And the reality is, if a project were to come in today, they can apply under the stormwater manual to use these practices, and there is no monitoring required. In the case of Kingdom Community Wind, and I believe in Deerfield, they applied just before or during the transition adoption of that standard. So they do have monitoring requirements, and will, as Jeff described, we'll be continuing to move forward with that, with those requirements, ensuring that that study's done. Speaking to the timeline, in the case of Kingdom, the monitoring could have started last year. We have taken the time, and arguably could have taken the time earlier in the permit cycle, to ensure that the monitoring, the study program was as good as it can be. So we are getting the best data we can to evaluate that system. I think that time was well spent. We haven't done many other alternative practices, and certainly so we weren't fully accustomed to ensuring that we had the study plan we needed at the time the permit was adopted. We sort of had a general one, and then as we got closer to implementing it, we realized there were additional modifications that we would like to see. So we took that time to get those study details right.
Why did you drop the monitoring requirement for more recent systems? Where was the body of data that increased your confidence in this system so that it was no longer alternative, it no longer had the higher monitoring standard? I'm just curious how that all came about.
Well, under the stormwater manual, if a practice isn't in the manual, you need to undertake a study. We can make revisions to the manual through a rulemaking process. So basically, drawing on the expertise of the stormwater program, our stakeholders, environmental community, looking at other practices in other states that are, like Maine has a robust roads management program, more geared towards forestry management, but applicable to wind projects as well. Reviewing information regarding what level of development can a watershed tolerate before it starts to experience degradation, and so forth. That's the general approach we use to revise the manual. So once that practice is in the manual, it ceases to be alternative. You don't need to do specific monitoring. There aren't a lot of, I would argue that the watershed hydrology protection credit is probably, if not the best, one of the best road management standards in place. Having said that, they're not easy to monitor. You can't go to the International Stormwater Database and say, okay, who's using this practice? I don't think anybody truly is. So there's a dearth of data, but collectively we understood that this was a good direction to, or a good option to provide this type of development versus having them continue to comply with the existing stormwater manual.
So the study that will be done will actually be adding to the overall knowledge base
Absolutely.
of how these systems are operated.
Correct. The study, the inspections that we undertake, there's been claims that, we've not been monitoring this project. In my 16 years with the stormwater program, I don't think we've dedicated more time to any other project. But we do have our inspections by Green Mountain Power. We'll have the study results, but perhaps most importantly, we have the biomonitoring results as well. We don't have that for most projects.
I'm confused about what the rationale is that you presented for not testing well, I'll just say level spreaders in ongoing projects now. I think I heard it's not alternative anymore, so you don't need to, and there's stuff in the new manual that's coming out that reinforces the need not to test, and yet you don't have any results yet. So help me understand that, the disparity of no results yet, but you figured out it's okay and don't need to test other projects.
Sure. Again, we were directed by the legislature to come up
with that.
Sorry?
Excuse me, I interrupted. Go ahead.
We were directed by the legislature to develop alternative standards. I shouldn't use alternative, that confuses the issue. Additional standards that high elevation renewable energy projects could use, and to update the stormwater manual to do that.
And that's
We drew upon the best available information regarding what types of practices were out there to manage runoff from typically steep high elevation roads and other development in those settings. And that's what led to the development of the watershed hydrology protection credit. Again, there isn't any monitoring data out there or available nationally that would fully capture the suite of practices that encompass that credit. But we collectively, again, not just the department, but the stakeholders that participated in the updated stormwater manual believed it was worth it to go forward, absent specific monitoring information.
Okay.
Sort of the same question I asked Jeff, even though this monitoring thing is sort of a permanent violation, I know you're getting that up and running.
Well, I don't believe it is a permanent violation.
Okay, all right, regardless of that condition 14, there haven't been any compromise that you know of water quality.
None that I'm aware of, no.
Thank you.
Other questions? And I will admit up front, some specific reading in the proposed manual, but there is not specifically a level spreader as a technique. There's disconnection and other things that obviously gets to, I think, the point that Jeff made, or you made, that you want to get the water out of the ditch, and et cetera. And so there are various treatments that get the water out of the ditch, but specifically a level spreader is not in the manual that I can see, or the proposed manual.
That's correct. So we do have the watershed hydrology protection credit, and the level spreaders are part of that. And when we developed that credit, we didn't build around level spreaders. We built around the concept of what roads perform well in those settings. What suite of practices are going to result in water quality being maintained, and that is not overly collecting, providing sufficient buffers between the pervious surface and the receiving water, ensuring that forest cover is retained, limiting the relative amount of development in that watershed. Level spreaders, you know, entered into that suite of practices as we looked into what's okay. If we have limited how long the ditch can be before you shunt the water off, how do you disperse that water back out versus just letting the culvert end? You know, under the AMPs, forestry AMPs, acceptable management practices, depending on the slope of the road, that dictates the level of how frequently you have to put in a culvert. We follow a similar model, but we have the level spreader on the outfall to ensure that that water is dispersed, and we also have requirements as to how far that level spreader is from the stream. You know, I'm not here to knock the AMPs at all. I've worked with them on my own skidoo trails, and I thought they were great guys. But we've taken it a step further, whereas the AMPs don't address the distance from the end of the culvert to the receiving water.
So working on the premise you don't get invited to the dance, that's yourself. It'd be a great benefit to me, and I bet the committees of jurisdiction in both bodies, to have DEC invite us to look at the various methods on this project. I've been on no, over the summer. And Green Mountain Power is a standing invitation for us all to go. That's a standardized tour that does not include the finer points that we're talking about, and I think it would be very useful if a joint presentation by Green Mountain Power and GEC were zeroed actually in on these practices. And I would look forward to an invitation.
Sure,
My feelings won't be hurt if it doesn't materialize, but
no. Yeah, we're more than willing to work with Green Mountain Power to arrange that.
thank you. I see Robert Doss is for the record shaking his head. Yes.
Okay, so we're about to get, the House is about to get a siting bill from the Senate relative to wind and solar and whatever. Have you or your division been involved with developing the standards for siting relative to water in that bill? Because that's the next challenge for this committee coming up.
I haven't been involved. I mean, aside from sort of the odd casual question within that work.
The
I can't.
agency familiar with
But certainly the
bill
agency's actually involved. Just speaking strictly with
Yeah,
stormwater.
no, maybe it was the wrong question.
No,
I'm just trying to
that's
make
fine.
sure I'm asking the right question, and I get some feedback on water review in terms of that bill,
Sure.
if you would.
Billy Coster has been the
For the
point
record.
person. For the record, this is Rebecca Ellis from DEC. And the person from ANR who's been the point person on that bill is Billy Coster, Director of Planning.
Director of Planning, okay.
One last thing I would add on the,
Yes.
sorry to,
Yeah, no,
on the watershed hydrology protection credit, the question to us as we're in the process of updating the stormwater manual is, should we make it more broadly applicable? Certainly, my personal inclination is yes, to make it more broadly applicable, but that's a conversation we're having, not just limited to renewable energy, and I actually believe it's also applicable to telecom facilities. That was a legislative action that directed that. But from our observations of them to date, I don't think there's any reason to limit them. But we do have additional monitoring data coming, so we're working through that issue with our stakeholders at this point.
so in order to get the data out of this project, we ought to think wet for the summer, right?
Yeah, that hasn't been a problem lately, but
Yeah.
we'll see.
Yeah. All right, other questions from anyone? The bells are ringing, folks. Thank you.
Welcome. Thank you.